Okay, let's take a look at this question. Find the Maclaurin series for the function f of x equals x divided by 4x plus 1. This is a type of question where we will use the Taylor series formula indirectly to find the required series. So first of all, we need to figure out which template, which formula we should use to write out a series. According to the form of the given function, which is a fraction, it looks very similar to the geometric series, which is sigma x raised to n equals 1 divided by 1 minus x, with this interval of convergence being absolute value of x less than 1. Okay. In order to use this formula, we will need to change our given function in the form of a right-hand side so that we can write that as the series on the left-hand side. So we notice that we have x on the top where we don't have it here on this one, so we will need to try to move it away by rewriting this function, and that technique we know is called the partial fraction. We see x can be written as 1 over 4 times 4x plus 1 minus 1 over 4. Because if you multiply this 1 over 4 with 4, that is exactly x, and this 1 over 4 multiplied with 1 will get cancelled with this negative 1 over 4 later. So that's exactly how we rewrite this x. The reason why we rewrite it in this way is because we want to match the denominator 4x plus 1. So later we will be able to split this fraction into 2. Okay, now let's replace x with this expression, just copying and paste, and then we're gonna divide by the denominator for x plus 1. Okay, so this part divided by the bottom is gonna leave us with 1 over 4, and then the second part we're gonna have a negative 1 over 4 on the top divided by the same bottom for x plus 1. Okay, we see that we are already one step closer to using the formula, because now the top x has been moved away and then leaving us with this. But we still need to rewrite this further in order to match this, because you have 1 minus x here, but you don't have, you have the plus 4x here. Okay, so instead of writing this, we're gonna write that as 1 minus negative 4x. And then in the same time, we want to factor this negative 1 over 4, so it becomes the coefficient, and then we're going to leave 1 on the top. So now it's going to completely match what is given in the formula. One thing we should emphasize here is the symbol x here is not just limited to a single letter x, but it could be any expression. In other words, we should see this template as something raised to power of n is going to equal to 1 divided by 1 minus this something. And that something could be anything, as long as the radius, okay, absolute value of this something is less than 1. Okay, and apparently in this case, the something that we're looking at is going to be negative 4x. Okay, negative 4x is going to be filled in this template. Okay, so it's very clear that we should replace now this part, right, with the series on the left hand side. So we're going to get 1 over 4 plus this coefficient multiplied with sigma, and from 0 to infinity, something raised to power n, which is negative 4x raised to power n. As soon as we write out this formula, we need to be aware that the interval of convergence is going to be negative 4x absolute value less than 1, because that's where the previous expression is equal to this expression, Without this step is not going to be valid. So we need to constantly keep that in mind. Okay, so this question is almost done, except we might need to do a little simplification at this step here. Okay, so we can continue writing this, and then -1/4, and then for the sigma, we can have this -4 raised to -1 raised to n multiplied with 4 raised to n, and then x raised to n. Okay, and then this interval of convergence, we can just solve this inequality, so that becomes absolute value of x less than 1/4, right? Which is going to give us the interval x is between -1/4 and 1/4, which we will present later. Okay, now this can be further reduced to 1/4 plus, right? If you sort of multiply this one inside, then you're gonna turn this into -1 multiply raised to power n plus 1, and then this 4 raised to power n multiplied with this 1/4 is gonna be 4 raised to n minus 1. Okay, so that is -1 raised to n plus 1, and then 4 raised to n minus 1 x power n. Okay, and since now you have a constant term 1/4, where could be potentially simplified with the constant term that is in this sigma notation, this summation, when n is replaced with 0. So you can further simplify that to kind of make it look better, but this is pretty much already the solution. Let's try to simplify this. When n is 0, we see that the first term can be written as -1 raised to 0 plus 1, that is 1, right? And then 4 raised to -1, which is 1/4, and then x raised to 0, which is going to be 1. And then the remaining terms is going to be summation starts with 1, that is this. So what I'm doing in this step is that I am splitting this summation where n starts from 0 into 2 parts. So this part is the first term where n is equal to 0, and then we pick up from the second term when n is equal to 1 to continue the series. And then what we see here is this 1/4 can be cancelled with this constant term that is taken away from the entire series, so we can cross them out to simplify the series. So the final answer of this series is going to be this 4 raised to n minus 1 multiplied with x raised to power n. Okay, so that's it. And then let's also take a look at the second part. The second part asks us to find a Taylor series about x equal to 1. Okay, so the process pretty much similar, except that we want to expand the series at x minus 1, that requires us to have this part here to be in terms of x minus 1 instead of in terms of x. So what we should think about is how we can create that x minus 1 expression in our function before we apply the formula. Okay, so let's copy and paste the formula here to be prepared. Okay, so we know what we need we want the expression of x minus 1, right? And then the first step is going to be the same. We want to move this x away, so we're going to continue to copy. We want it up to here, okay, up to this step maybe, okay, up to this step. Okay, continuing from this step, what we're gonna do is, so it was 4x plus 1, right? It was 4x plus 1. So what we're gonna do is we're gonna write 4 times x minus 1 instead of x. In the same time, we need to compensate for that negative 1, right? So instead of plus 1 here, we should have plus 5. So now we can calculate 4x minus 4 plus 5 is exactly the same as 4x plus 1. But by doing so, although we have created this x minus 1, but in the same time you have lost the 1 here, which is in the template, right? So you need to recreate this one in order for you to be able to use the template. We talked about that. That is, can be done by dividing the top and the bottom by 5, okay? Dividing the top and the bottom by 5, so I can have 1 over 5 on the top, and then the bottom I have 4 divided by 5, x minus 1 plus 1, right? So now we can see that I have this 1 here, and then I also have this x minus 1. Okay, then we're gonna rewrite this into 1 over 5 divided by 1 minus this, right? Instead of 1 plus 4 over 5 x minus 1, in order to use our formula, the template, where the box here is going to be replaced with negative 4 over 5 x minus 1. Okay, so now we can replace that expression. This 1 over 5 is going to factor out, right, with the left hand side in the template, that is sigma, and from 0 to infinity, something raised to power n, where something is 4 over 5 x minus 1. And then same as before, you can open the bracket to simplify this, and then this can be simplified to negative 1 over 20, right? Sigma, and from 0 to infinity, and then we have negative 1 raised to n, and then also 4 over 5 raised to n, so that will be 4n divided by 5n x minus 1 raised to n, right, which is what we desire to find. But don't forget the condition where this is equal to that is exactly the interval of convergence, which is obtained by letting the box, right? So here we have negative 4 over 5 x minus 1 absolute value less than 1. Okay. We can go ahead to solve this inequality. That's going to give us x minus 1 absolute value less than 5 over 4, right? We open the absolute value, that gives us x minus 1 less than 4 over 5, and then greater than negative 4 over 5, which is equivalent to x less than 9 over 4 and greater than negative 1 over 4. Okay, so now we have our interval of convergence found here. And then just like before, you can simplify this by canceling the constant term in this series with this one. Okay, but before that, maybe we can do a little simplification. Okay. I just realized I don't have to multiply that, because this got multiplied inside, probably it's gonna simplify further. Okay, so gonna keep that as negative 1 over 4 multiplied with this, right? And then if you multiply that inside, it's gonna give us sigma n from 0 to infinity, and then -1 raised to n plus 1, and then this 4 cancel with this one, so we have 4 raised to n minus 1, and then 5 raised to n plus 1, and then x minus 1 raised to n. Then, like before, we're going to split this series into the constant term where n is equal to 0, so we have a -1, it's the first term, and then 4 raised to, this one is going to give us 4 raised to -1, so that's 1 over 4, and then 1 over 5. Okay, 0 give us this 1 over 5, and then x minus 1 raised to 0, and then the rest of the series from 1 to infinity. That's a little bit long to write. 4n minus 1, 5n plus 1, x minus 1 raised to n. Okay, hope I don't make any mistake. And then let's see if we can cancel, right? This term is going to be -1 over 20, and this one is going to be 1 over 4. So what is 1 over 4 minus 1 over 20? Okay, 1 over 4 minus 1 over 20, so that's going to be 20 over 20, what is that? 20 over 5 over 20 minus 1 over 20. That's 4 over 20, so that is 1 over 5. Exactly. Okay, so this one is going to give us 1 over 5. To hate this calculation. 1 over 5, and then plus the remaining thing, and then put our interval of convergence here. Okay, that is this question.